Greg Orloff with IoT World, and I'm here with Mark Fairlett. And Mark is the Director of Marketing for the Indy Autonomous Challenge. So Mark, welcome.
Thank you, Greg.
Tell us a little bit about what the challenge entails. We got autonomous vehicles here behind me. So
the Indy Autonomous Challenge is inspired off the 2004 and 2011 DARPA Grand Challenges, which are essentially student competitions designed to accelerate the development and the adoption and commercialization of ADAS and autonomous technology in the private market.
Okay.
We essentially decided that we would look for a new approach to automation and autonomy that would focus on high-speed autonomy. When you look at the market today, you'll notice that a lot of the providers focus on, let's say, urban to suburban robo-taxi services. You have the Waymos, the Cruises of this world, right?
Right.
But no one is actually looking at high speed. Right? And no one, as a result, is developing the technology and proofing the software and the sensors and the components to make that technology work at those speeds. And we're talking all the speeds going above 70 miles per hour up to 200 miles per hour.
Got it. Okay, so that's the high end of the spectrum then.
It is. It's all the applications that relate to high-speed transportation across already existing public infrastructure such as highways and essentially all the applications where you're not replacing an Uber driver, but you're actually trying to move around freight, move around, let's say, time-sensitive payloads between two cities that may now have airports.
Gotcha.
And applications such as that. Now, the reason why we started as a non-for-profit, right, because we are a 501c6, so we have sponsors, as you can see all over the car, right, is because we wanted to involve the private sector in our research. We wanted essentially to get academia, the private sector, and the government to work together collaboratively to increase the pace of development and the access of development, right? So the private sector are mostly component manufacturers, and you'll see once we go into the car, the LiDARs, the radars, the cameras that are all provided by companies that sponsor us. And they do so because they'd like to test their technology at very high speeds. It's an opportunity that they can't have in a private sector play alone, that they can't financially do, with viability.
Great concept. So the universities then compete? Is that kind of how it's
That's
structured?
correct.
Then? Is there like a boilerplate? Each car is essentially the same, or what? Where's the differentiation come from in the competition?
So this is one of 11 cars. This is a show car here.
Okay.
We have 10 other ones in a garage in Indianapolis. And universities essentially join together or go by themselves and create a team, right? Where they then purchase a car, right? And their job is to code the AI that's then uploaded into the car. So as you said, every car is identical. It's got the same number of LiDARs, the same number of cameras, the exact same setup. Of course, there's always a tiny bit of difference.
Sure. Same drivetrain though, essentially.
Exactly, right? So this is all based, by the way, on a Dallara Indy Light chassis, which is the little brother of IndyCar, right? Just a bit smaller. It's still an open wheel race car, so vehicle dynamics become very important. And then the university teams, which consist of universities such as Berkeley, MIT, Pittsburgh, and so much more, also internationally, Politecnico Milano, even universities in Korea, they compete to code the fastest AI driver. So it's purely a software battle when you look at it that way.
Interesting. High-speed software.
Exactly. Very high-speed software, and importantly, multi-agent scenarios, because the way the competitions work is through essentially a passing challenge, where two university teams, and hopefully soon three, are side by side on the grid and pass each other, one after the other at ever-increasing speeds, until one of the cars either yields or has a technical malfunction that forces it to stop. And then it's up to the AI in the car to decide when to yield or when to make the pass, and how to make the pass, what line to take, whether outside or inside.
So it's doing those calculations and making those decisions.
Correct.
Wow.
So we have a very big computer inside called a Altera Autobox, which is a computer provided by a German company called D-Space.
Okay.
This computer essentially manages all the, let's say, strategic thinking of the car. So these are the 1 to 4 second decisions that you'll do when, for example, you're merging on the highway, when you have to take a bunch of factors into consideration.
Yeah.
And then we have something called the Raptor engine, which is low-level firmware, which does all the subconscious decisions that you don't even think about when we're driving. For example, how much pressure am I applying to the steering wheel? Or how many degrees am I turning my steering wheel? Or how much am I pressing on the throttle?
Interesting, fantastic. So if somebody wanted to get a hold of you, we'll make sure we put a link in the video.
Absolutely, please do.
Sponsorship standpoint, or now when's the next race? When's the next competition?
Yeah, so on September 6th at the Indianapolis Motor Speedway, we'll be racing with all 10 cars. We'll have our universities flying from Italy, from Korea, from Canada, of course from the US, and they're going to compete for a $1 million prize to see who can code the fastest AI driver. It's going to be our most advanced race to date. We have our newest car. This is, by the way, the AV24, so it's the latest edition. It's got custom drive-by-wire, the newest set of LiDARs, cameras, and we're going to try to push it to the limits. And it's not just going to be a race. We're also really involved as a non-for-profit in involving STEM students and high school students too, right? And trying to get them engaged and involved in the future of robotics and showing them career paths and how to get to the point where you can be a university student working on the most advanced self-driving car.
Fantastic. All right, so once again, any of the school systems out there, if you want to reach out, we'll make sure we put links in the thing. Thanks.
Thank you very much, Greg.